Okay, so in this question, two letters are chosen from the word tree without replacement. So what that essentially means is if we have a sack that has wooden letters in it with T, R, E and E inside there, or maybe a Scrabble bag or something, and we were to pick out a letter, we might be able to pick out the letter E, for instance, and then we'd pick out a second letter and we would pick out, let's say, an R. We might also be able to pick out a letter in another choice, an R, then the R does not get put back in the bag, and we could pick out a letter T, for instance. So there's some examples of letters that we might choose from the word tree. Now if we want to list the outcomes in a table for this experiment, then what we want to do is think about the choices we have. We've got the first time we pick out a letter, and then we have the second letter that we pick out. Now each time we pick out that letter, we have the choices of those four letters. We have a T, an R, an E, or an E the first time. Now because we're not sure which letter we picked out, the first time in the second choice we have to assume that we've got available all four letters. Now when there's no replacement, options such as T, T don't exist, neither does R, R, because that letter's been taken out. And if we talk about the third E in the word, that option doesn't exist, or the fourth letter, the fourth E together don't exist either. Now what we do is we now have a look at what other outcomes are possible. Okay, we could get a T with an R, a T with an E, and also again a T with an E. We could have an R with our T, an R with an E, and again an R with an E. We can also have an E and a T, E and an R, and then we can have an E and an E. Then again we can have an E and a T, an E and an R, an E and an E. So the EE possibility does exist, but just as long as it's not the same E. So that's completing part A of the question. Now part B, it asks us to find the probability that the two letters chosen are both E. So it's asking us for the probability of E and E. Now how we can do that is we look at our table and we look through the outcomes and we say to ourselves, okay, how many outcomes have we listed here? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our sample space available is 12. That's the number of outcomes available in the sample space, which we would call elements in the sample space is equal to 12. From that we need to count ourselves up which ones are E and E. So we look, we have an EE here, EE here, no. So we've got two possible outcomes of getting the probability of picking out the letter E and E. So the way we write this then for part B is the probability E equals 2 out of 12. Now we always like to simplify our fractions, and we can see that 2 over 12, 2 divides into itself once and it divides into 12 6 times, so that our probability is 1 in 6. So there's a 1 in 6 chance of picking out EE. Okay, I'm going to make a new slide for part C. So here we have our table, and for part C, not part B, the question has asked us what is the probability of it getting at least 1e. So we write that as the probability of at least 1e, like so. Now, we do, as we did before, we look through our table of outcomes and we count up how many of these outcomes have an e in them. So we have a look and we say to ourselves, okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means there's 10 possible outcomes of getting an E. So that would be the fraction 10 over our number of samples, let's make that more clear, of 12. Now, as we did before, we simplify our fraction, which becomes dividing by 2. 10 divided by 2 is 5, 12 divided by 2 is 6, and our probability is 5 over 6.